Okay, and other video concerning the simple beam model. So I have received many questions about how to prescribe the section properties. So as I told before, there are two methods. So the first one that works in all cases here is to directly prescribe the geometric and material properties of the section. So instead of prescribing the geometry of the section, so here you will not enter the geometry. You will not say it's a box or it's a pipe or a rectangle. You will directly enter the equivalent section and the equivalent second moment of area. So to do that here, so you will select, so here, if I go back here to the property, what you do, so finally, you don't need to enter material properties. You can directly go to section, and here you choose beam, continue. Okay, so now the first method here is to choose a general section. So to do that, what you have to do is to first select before analysis. And then here you will have lots of parameters. So the parameters that you will have to enter here, if I go back to the slides, so you will have to enter the equivalent Young's modulus. And here it is asked you to enter the shear modulus. So the shear modulus formula is this one. So you will just calculate the equivalent shear modulus and you put the value here. Then here you put the Poisson's ratio, the equivalent one, and here the equivalent mass density here. Okay, that's it. So then you tick this button here and you select generalized. Okay, and then here you don't need to enter the dimension of a section. You directly enter here the equivalent section and the equivalent second moment of area here. And for the rest of the parameters, you can put them 0. And something important is that you can only do that for a 2D model. Okay, so you cannot. So when you construct your model, it has to be a 2D. So this is when you construct your part here. So you need to select 2D here and wire. Okay, you cannot select a 3D wire if you are using this first method. Okay, so the second method, the alternate one here, is to as I have already said before, you can replace your complex geometry. So for the simple model, you can replace the complex section by a simple one. So for instance, a hollowed rectangle or a hollowed circle here. Why hollowed? Because you need two parameters to fit both the second moment of area and the section. Okay, so for these both simple sections, you have here the formulas on how to calculate the section area and the second moment of area here, depending on the dimensions, and then you can revert this, inverse these relations to get the values that you should enter for B1 and B2. Okay, you can do that. So this method is easy, but the problem is that for some specific parameters, it can happen that you find a B1 negative. So for instance, this can happen if, for instance, you choose just one reinforcement that is very rigid. And in this case, it's impossible to replace your section by a simple one. Okay. Then in this case, you have to go back to the previous method. Okay. Otherwise, you can use this method, and the advantage of this method is that it can be used for a 3D model. You can construct a 3D simple beam model instead of simple 2D beam model. Okay. So so that's it. So and here I just remind you the remark that I said before. Okay. And just one last remark here as a complement. So when you will do your comparison, where is it? It's here. Sorry. It's here. So I've added a remark here. You will compare these two models here. You will compare this model and this one. So you will calculate, if you do a buckling analysis or a model analysis, you will have lots of modes. For instance, for a model analysis, you will have the flexural, the bending modes here, the first one, the second one. You will also have a torsion mode, okay? But here, if you use, for instance, a simple 2D models, here you will have less modes than the number of the modes that you will get with the full model. For instance, here in 2D, you cannot have the torsional modes. And also here for the bending modes, you will have bending modes. Each mode will be repeated in two directions. You will have a mode in the direction here of your screen, and you will also have the same mode, but in the direction orthogonal to your screen by symmetry. But here, if you have a 2D models, the modes will not be repeated because it's 2D. So if you compare the bending modes, be careful to do a correspondence between the modes of the simple model and the modes of the full model. Okay. For instance, the third mode of the simple model maybe will not be the third mode of the full model, because here you will have more modes in this model than in this one. So if you compare the frequencies of each model analysis, be careful to do the modal correspondence between the two modes. Okay. So the best is to see that on an example here. For instance, let me open the mode of the full model here. Okay, so let's do a model analysis here. So we do step here. We'll replace the previous step here by model analysis. So I will choose here linear perturbation frequency. Okay. Subspace. Here I will choose, for instance, 10 modes. Okay. Just remove the previous one. Okay. So here, normally I have to reconstruct boundary conditions. Yes. So we just so for the model analysis there is no loads. Huh? So we just need to here prescribe the boundary conditions. We just block this surface here. Okay. So here boundary condition. Continue. So all these degrees of freedom will be blocked. Okay. So I think everything is done. Interaction normally it's still there. Okay, it's still there. Okay. So I can go directly to job. Submit. Okay, just pause the video. Okay, so the calculation is completed. So let's have a look at the results. Okay. So this is the first mode at 36 Hertz for my model. So if we look at it, okay, you can see that you have this bending mode in this direction here. So if I look at the second mode here, you can see that it's also at 36 by symmetry. Here I have the same mode, but in the other direction. So for the simple 2D model, you will have only one mode in the direction of the plan. So if I go now to the third direction, so you have this mode. Again, you see that it is duplicated. You have the same mode at 220 Hertz. You'll have only one for the 1D model. And here you have this torsional mode. You can see the torsion of the beam. So here, this torsional mode, you will not have it for the simple 2D model, okay? So that means that the fifth mode here will not correspond to the fifth mode of the simple 1D model. So finally, the three modes that you will calculate for the simple beam model, it will be, you will find the first one. So you'll have to compare the first mode of your simple 2D model with this value. Then you skip this one and you go to the third one, and you will get the second mode for your simple 2D model. And you will not have this one, you will not have this one. And the third mode will be this one for your simple 2D model. So these are the values that you will have to compare. Okay, thank you for your attention.